Dann begrüßen wir ihn mit einem großen Applaus. Herzlich willkommen, Professor Dr. Yasuyuki Nishioka. Herzlich willkommen.
So, ladies and gentlemen, I'm very honored to be here again to make a presentation about our reference architecture from Japanese point of view. So, industrial value chain reference architecture was published last December. I believe that this reference architecture contributes to Rami 4.0 or many other reference architecture in the world. So today, I'd like to talk about the reference architecture, but in the beginning, I'm briefly about the introduction of our organization, IVI. And also, oh, sorry. And also, I'd like to show you about the use cases we obtained last year. We had 25 use cases and several examples also be presented. And then our approach, bottom-up, will be explained a little bit about. Before we go to the IVRA reference architecture. And finally, I'd like to propose the platform of IVI. This is the implementation view using under the reference architecture. Okay. So let me introduce about our organization. So in Japan, we have 3 major organizations for industrial IoT. One is IoT Acceleration Consortium. It covers many industries, not only the manufacturing. And also the Robot Revolution initiative covered Robot Revolution. And we are here in the Industrial Value Chain Initiative for manufacturing industry. So, working group 1 of Robot Revolution Initiative, and we are covered manufacturing. So most of the members are manufacturing industries. Now we have 128 members from industry, and almost 40% are SMEs. And our activity are mainly business cooperation committee, which are managed, organized, the business scenario working group. And also, this year, we start future project committee, which are focusing the future dream project. Comparing to the business cooperation committee, a very, very bottom-up approach. We already have many, many use cases, but the future project is a little more future works. And also, the standard model committee, platform committee are working for the reference architecture and developing the set of the modeling of the standards. So here you can see the several scenario working group outputs. So you can see more than many, many scenarios, which are kind of the use cases. And each working group are very, very practical and very detailed for the shop floor concern. And many these topics are categorized into 8. One is the production engineering, quality management, and production planning and control, supply chain management, SME, preventive maintenance, asset and equipment management, and also the maintenance service management. So this is categorized for how to develop, how to go to the implementation from the business side to the IT side. I will explain this later. So to make a line picture, these 8 categories can be mapped on the several dimensions. So one dimension could be like this. There are business functions, the product engineering, quality management, and so on. And this main stream are the within enterprise. But also we are focusing on the between enterprise like this. And several other, the view is the granularity or single process for the SME or a whole process like this. So let me explain about one example obtained from one working group. So this working group are focusing on welding process of fluid valve makers, SMEs. So this use case or scenario, there are very problem in the welding testing. At the beginning, they are focused. They do the destructive sampling for inspection, but they want to go to the more data-oriented approach, and they want to non-destructive testing using data and IoT. On the other hand, in order to reduce cost, the welding touch replaced every fix 30 times or 40 times after. But using the data, they can move to more and more efficient usage of the welding touch consumption. So in order to do that, they go to the real situation, making a scenario, and finally they get a kind of the test bed. So here you can see the graph on the right side. They had 2 main sensors on the test bed. One is the fluctuation testing, gathering the many data on the real time. Other one, AE, acoustic emission. This is also very valuable data. So good situation, bad situation, good and bad, means you can see from the data. So they decided to change the situation, move to more and more efficient, more quality, high quality approach. For example, this is a graph for the correlation between data and welding penetration. So this means, this is bad case, good case. So in this use case shows the data-oriented testing or data-oriented facility control can be available like this. So in the past, here they have to change every time, and using the IoT technology collaboratively, they changing time is moving to here. So they calculated that the total cost saving will be 100,000 euro per year. So this is one example, but we have many, many use cases doing our collaborative approach from the bottom up. Okay, so let's go to our bottom-up approach. So now I'd like to introduce the smart manufacturing unit. This is a basic unit to establish the whole smart manufacturing from bottom up. We have a three views in the smart manufacturing unit. The important point is the unit has human being. Here, assets include plant, product, process, and also personnel in the shop floor. They can change, they can think about how to make more and more efficient for the shop floor itself. So here, the personnel is the center, and there are some assets, plant, and product. And also here, you can see the management view of the human personnel. So we are very, very human-oriented approach from the beginning. So in the process of our scenario making approach, one is as-is situation, and after that, they can try to make the future to be scenario. And going to the beginning to the future, we focus to 4 steps for the self-improvement. So plan, do, check, and action. This is a very important concept of our smart manufacturing unit. So here you can see the plan. Think about what have to do for the production, and do means doing something in the floor to make a product. And after that, they have to check how much it is valuable or not. And finally, process, this is very important because the guy can be change the product, plant, and information product, information process by themselves. Then the process, flat shop floor itself can be moved to the next stage. So each working group starts from scratch every year, every cycle. And last year, we used this kind of digital tool to make a model of the scenario for the use cases. So the right side is the picture to make the scenario in the physical world, in the shop floor. On the other hand, the left side means the cyber world, because physical world, cyber world are both important and get together to make the final implementation for the smart manufacturing. So let me explain about how we are connected each other between physical world and cyber world. So now the actor is very important role, but they have to do something in the floor. So activity action is an element of the modeling in the physical world. And also, we can see the information and things. That's everything for the physical world. And on the cyber world, of course, we have to have data and information. And here you can see the things has a digital mark, which means things can be connected to the cyber world. And cyber world, we make everything for the information technology. And at the end of the day, they can show the digital from the cyber world to the physical world. This is a very, very simple picture for the modeling of our approach. So we had the object model for this modeling. The right side is very easy to understand from the shop floor person or business person, but IT person is very familiar with the right side, you know? So this is the bottom-up approach of IBI modeling and IBI business scenario approach, but we understand that the bottom-up itself is not perfect because of the integration or commonization of the data in order to make interoperability. So here we have to have the several layers of the data model. One is the data model for the component. This is the actual implementation data schema. But also, they have a platform common data model in order to make interoperability using this component profile. This is also very common approach. And if the platform have to connect each other, then we have to have this kind of the domain data model. So we had 8 categories right now. So 8 specifications for the domain reference data model right now. So this is the basic picture for our loosely defined standard. So loosely defined standard is very, very difficult to understand, but it's only the concept how to make a standard, how to make a common data model from the bottom-up approach. So this only shows that the common data model can be defined every time depending on the situation of the shop floor, not from the top down, not for the super specification there. But they can define from scratch, referring to the upside model and making change depending on the real situation. This is idea of our reference architecture. So let's go to the reference architecture and comparing to the Rami 4.0. So I already mentioned about the smart manufacturing unit, which has 3 different views. And also from the top-down approach, enterprise has several functions which we define as a general function block. But this is very common approach. But important point here is we can map the smart manufacturing unit to any granularity of the whole enterprise model. For example, one enterprise wholly correspond to the one smart manufacturing unit, and another management concept, there have several small units for smart manufacturing unit, which are very, very self-organized or very autonomous modeling, autonomous changing, autonomous management. So it depends on the situation of the company. So we also have another model of the smart manufacturing. So here you can see if the connected factory have to be defined, have to be implemented between enterprise, between whole of the world, then not only the inside of the enterprise, but also the between the smart manufacturing units. So now we define the portable loading unit, which has a portable asset and also data and value, because different organizations have to define the value chain. They have to pay for the product or material or information data. So we have to have this kind of the modeling scheme, which has not only the things, information, data, but also the value. So this is but only the concept. So now I have to explain about the relation between Lamy model and our approach. So the first layer of Lamy 4.0, asset layer are corresponding to our asset view. And also the business layer, you will have some view from the, can be defined the view. So this is corresponding to this layer. And PDCA model, cyclic improvement, may be corresponding to this one and this one. So this is also the cyclic, not only the one way from our view, but maybe the type instance are corresponding to this, and return recursive way have to be done. And administration shell, as you know, there is an asset for the administration shell. So I think here are corresponding to the physical layer, and the cyber layer are also there in the Lamy 4.0. And we had SMU and PLU, but I think it is very similar to the industrial data space. This is not the Lamy model, but I know about the data space because I think here reliable connection center have to deal with the data traceability, the object things traceability, information traceability, and connection between cyber world and physical world. So maybe this is very similar to the model of the industrial data space. But I'm not sure, but I have to more and more discuss about the approach. OK, so let me finalize our introduction. But I want to propose about IVI platform, because the reference architecture itself doesn't care about the implementation. So now we have a platform composed by four groups, four categories: the application, infrastructure, device, and tool. This is the basic parts of the platform. So platform have to be these three concepts if they can tell this is IVI-like platform. So we define many use cases for the platform for many use cases to support how to implement their own use cases by defining the 8 category, 8 reference model, and also we define 10. Now we have a 10 platform project. One is a single, but some projects are consortium. So once each platformer define what is your category, so up to 3 categories they can choose. And after that, they are each working group can choose their own platform and select the platform. And finally, there is 25 use cases, but 14 use cases are implemented by one of each platform. So last trial of our IVI implementation use this kind of platform ecosystem. So this is the final slide. The platform ecosystem we design right now is like this. So the platform provider, the IT industry, or component supplier have to follow the platform reference model that the standard committee define in advance. But we have to know about the reference model of the platform coming from the user's scenario, very, very practical information coming from this approach. So this is why we say we are the bottom-up approach to make a platform ecosystem. And now, first cycle is completely done. And we try to, again, to the next stage. Now we restart another use cases and another implementation for this year's. Thank you very much for your attention.